This video is going to show you how to take a concept, draw it in 3D CAD, a simple free CAD that you can use anywhere, and then mill it on the ShopBot. This is just going to be an outline, like cutting a part out, not rastering or putting images on it or anything. So to begin, we can open up, I'm going to open up Sketchup. This is just one free CAD software that you can use. There's lots of others out there, but this one is a really intuitive, simple one. Again, it's free, so that's the main thing. So what we're going to do is I'm going to draw a circle, and I'm going to type in, if you look at the bottom corner, it says radius at the bottom right. I'm going to type in 2 inches. The default for this template that I'm using here is in millimeters, but I'm going to use inches. And then I'm going to draw a little rectangle as well, and I'll just do it like that. So I have a circle and a rectangle, and I can move around using the mouse buttons and clicking, different views here. What I'm going to use to export this is a plugin, and so this plugin is from Flight of Ideas. You can find it many places online. Basically, you highlight the thing that you want and click SVG. This is going to create an SVG file, scaled vector graphics. So I'm going to locate the folder that I want to be in here. Do ignore all of my, that was my previous attempt at this. There we go. So please ignore all of my random files and whatnot, but I'm going to type a name for this, circlesquare.svg. I'm going to leave everything else by default, and in its default configuration, and click OK. And it has now created my file. So I can close SketchUp. You usually want to save this, but I don't really care. Now I'm going to open this in Inkscape. So let me see. I've got my Inkscape program here. I'm actually using a development version of Inkscape, so it's a little buggy, but if you download it from the website, you'll be able to use it. It loads much quicker from the website and does a nicer job here. There's my Inkscape. So now I'm going to open my file. Again, I'm going to go to my circle example. This is the file I just created, and I'm going to open it. So now I'm in Inkscape. These are objects of their own right here, so I can move them around and reconfigure them as needed. But what I plan to do here is I'm going to select all, Control A, go to Fill and Stroke, and I'm going to set the stroke style to inches and 0.001 inches. And it looks like they disappeared, but if you zoom in sufficiently, you can see them. Notice that this is the circle. Inkscape doesn't make circles. The way it makes circles is by making lots of tiny straight line segments. So that actually, you can adjust the number of lines that it uses, but we'll use the default for here. That actually can cause an issue later, so I'll mention that in just a moment. So what I'm going to do is I'm going to save this, and then I'm going to save it as a PDF document. And I'm going to save it in the same file. I'm going to use these settings. I've got PDF 1.5, convert text to paths if you have text, 600 DPI, use the documents page size, and then that's it. So I'm going to click OK, and it has saved my PDF. So now I can close this, and I can open Partworks. So Partworks is going to help me turn this file into something I can cut. So I'm going to go to my circle example PDF and open that. And in here, if I Okay, first you have to set up your job. So this says how big is the material you're using. I'm going to say I'll do 4 by 12 inches. And I'm going to use a 1/2 inch thick material, so 0.5 inch thickness. I'm going to deselect, use origin offset, and I'm going to keep it in inches, and I'm going to click OK. So now I can adjust the orientation of everything. First, if you notice, if I click something, it becomes pink. And here, the circle, I click something, and it becomes, just that one segment gets highlighted. So what I want to do is join all of those segments together so that they're a single file. I'm not going to group. That's a different operation. I'm going to join. So I'm going to highlight them all and hold down Shift if you want to pick up any of the loose ones. And I'm going to click this Join Open Vectors button and use the default settings and click Join. So now if I click this object, it's a single line. If you don't do this, then the SketchUp export will cut each segment all the way down. It takes like 4 different depth cuts, and then it will move to the next segment and do that again, and it takes forever. So just join them and you're good. I'm going to do the same thing with this rectangle up here. Join all that. Now I'm going to move everything to where I want it. That looks good. And actually what I want to do is I'm going to edit my job size. So 4 inches looks like it's a little too small. I'm going to say 4.5 inches, and that just gives me a little bit more space. So I can move my circle, have a nice border on either side. Here again it looks like maybe 12 inches is a little close. So I can adjust this again. Now typically what you would like to do is we want this to be in the orientation of the machine, so we would use 96 by 48, and this would be a solid piece of stock that you're using. This is your origin down here, and this is where the if you're looking top down on the machine, this is actually where the control panel box is here. It's always this way, so when you design things, keep that in mind. But what I'm going to do is just cut a small area of a larger piece, and I'm going to manually make an offset. And so that's going to allow me to use a smaller stock. So I'm going to use, again, I had 4.5 here, and I'm going to say 14 inches tall. So this gives me a little bit more space between my parts. And again, the origin is the bottom left corner. So now that I've got my parts approximately where I'd like them, I'm going to create my toolpath. Click Toolpaths, and we're going to say Create Profile Toolpath. The profile is going to be the cuts here. This cut is going to cut out the entire piece. You can also do like pockets and 3D carving and things like that. I'll cover that later. So these are the settings that you should use. We're going to have a start depth of 0 inches and a cut depth of 0.505 inches. You want to do a little bit deeper than your actual material. My stock is 0.5 inches, so this is going to cut a little bit past that to make sure it cuts out the part completely. You click Select on your tool, search for the tool that you're using. I'm using this 1/4 inch ball nose, and I'm using the default settings here because I'm cutting plywood. This works really well. So 12,000 RPM, 100 inches per minute, and the plunge rate of 30 inches per minute. Click Apply. OK. Here you can select whether you want to cut the outsides of these shapes or the insides of these shapes. That depends on what you want to do. If you want to cut out a hole in something, you want to cut out the insides of the shapes. The edge of the tool will cut out on the edge here. If you want to cut and have this square and have this circle as objects, you want to cut on the outside. Now it has climb and conventional. This just tells it which direction to cut, which side of the bit to cut on, because the bit spins a certain direction. Climb will actually do a cleaner cut usually, but it's harder on the tools. Conventional is a little faster, but it's a slightly rougher cut. I use conventional. I have no problem. As long as you're using a sharp end mill, you're fine. The next step is to do the tabs. The tabs will, if you imagine you cut this piece out, as soon as it's free, it's going to flop around and it might hit the bit, it might damage, it might actually get slung around. So you want to actually have little tabs in here to hold it in place, even as it cuts all the way through around it. And then you can come back with a razor or something later and pop that piece out. So you click Add Tabs to Toolpath. I've got it every half, or the length of the tab will be about a 1/2 inch. The thickness is about an 1/8 inch. Click Edit Tabs. You first have to select everything, so I'm going to Control A. Click Edit Tabs, and put the distance between your tabs here. And you can click Add Tabs, and it will add them where it thinks you need them. You can change this number, maybe 12 inches. Maybe I want it every 3 inches. So it can adjust where it puts the tabs. You could also click on them manually and move them about. Personally, I do not like tabs in the corner very much. So I'll remove those. And I'm going to also remove a couple from the circles, rearrange them. So now the tabs are approximately where I want them. I click Close, and I'm going to name this profile, Cut Profile 1, and I'm going to click Calculate. This is a warning telling me that I'm cutting deeper than my material. This is okay because I have a sacrificial piece under my material that I expect to get cut, and this makes sure that it'll cut all the way through my actual piece. So I'm going to click OK. And this is the simulation. You can see each line, it's going to cut a certain depth and then go down, cut the next line, and so forth. You can actually animate this if you want, and it can cut. It'll show you step by step where it cuts. Reset preview, and then yeah. So I'm good with that. That looks good. I'm going to save my toolpath, but I first need to select it and click this button, Save Toolpath. If you want to edit it, you can edit it here. If you want to delete it, you can delete it here, come up with a new toolpath, and so forth. So I'm going to save my toolpath, output all visible toolpaths. The only one I have selected is that one. I'm going to make this in my inches because that's what my machine is set up in, and I'm going to save it to a file. So it's cut profile 1.sbp. Click Save. And then we can close this software. I'm going to save the changes. No, I don't need to save those. And I'm going to open up the ShopBot software. So this is how you actually set up the hardware on the ShopBot. So first we need to pick out which bit we're using. The one that we selected in our software was the 1/4 inch ball nose end mill. And so we have this end mill. We need to get the appropriate size collet. So this is a 1/4 inch collet that we'll be using. The way we're going to use this is we're going to put this actually inside the spindle. So I'm going to move some of this stuff so you can see what I'm doing here. The spindle has this shroud around it, and we're going to have to remove that. So in the back there's a little thumb screw right where my hand is, and you can loosen that and it drops down, and that allows you to access the spindle head. So we take this off, and we're going to put the collet in like this, and then it gets supported inside like that. And of course our drill bit can go inside that. So we just start this. Be sure to support all of this as you're doing it. So we start that until it's just a little snug, and then we take our tools and tighten it. So this wrench, actually you can't grab it like a normal wrench here. We have to go under it and go up, and the teeth lock and it will not come off. So that's useful. And this is actually, this piece we're going to turn this direction. So we can keep that on this side. And this piece, the top, we're going to turn the opposite direction. So we've got this wrench, and it's actually a really tight fit. So now we're going to tighten that and make sure that it's really snug, because you do not want this flying off. Remove both of your tools. You can replace the shroud here, and you want the shroud to be just a little below where your bit is, possibly. Like, you don't want it to be any higher. So you want it to be a little bit below where your bit level is. We can tighten that thumb screw back up. And now that's ready to go. So we can clean off this area. Of course, we're going to be using safety goggles and hearing protection. So this is the way we've set up the ShopBot here. We have several cut sheets of 3/4 inch MDF that is bolted to the each spanner, and we put insets in here and bolts through the bottom. And that's really cool because we can adjust the height of each of these from the top based on the inset. And then the cutting area is like 10 foot by 5 foot, and we have this sacrificial piece here of, we were going to do 3/4 inch, but they sold out of it, so we got 1/2 inch MDF, and we've tacked it down in the corners. And this is actually 1 inch bigger on either side from being a 4x8 sheet, and that works pretty well because that gives us the ability to put our stock on top and have a 1/2 inch hang off on every edge. And so we can do our Z-axis over here, or our 0 over here, and still not hit our other places if we wanted. But the way that we're mounting this is we're screwing this directly down into the sacrificial material. And so we're using some pretty nice screws that are self-tapping screws, and they use a star bit. And so this is a 1 1/4 inch screw, and it's going through, this is a 1/2 inch on top and a 1/2 inch here, and then of course whatever, this is bottom piece, it's just going to be whatever's left. So so the way that works is you just go in and out to kind of get the chips out of the way, and that basically makes its own pilot hole. And then you screw it down tight, and it's actually even countersunk a bit. Yeah, zoom on that, right? So, and of course countersink everything. If we had 3/4 inch for the sacrificial material, it'd be better. But yeah, so mount this on all 4 corners, and when you cut, be sure to have tabs in your pieces so that they don't become free moving whenever they're actually cut out. At this point, the machine has been turned off, everything's off, and so the axes are loose, and we can actually move this if we wanted to, but we can turn it on and drive it, so that's going to be a much better route to go. So from this side, if you come around, I have a laptop here set up with the software we'll be using. So we created our cut job files here, and we need to run the program. So we're going to run ShopBot program, and when that loads, we can do a few things with it. So first, notice that we have several lights here. We need to turn the machine on. I forgot about that. So if this ever happens, just remember, turn the machine on here. The key should be out whenever you first turn it on. Everything's going to start up, and now we can click on retry connection with this port. Of course, you need to have the ShopBot 2 USB dongles plugged in. So, okay. Now this has seen that I have my ShopBot connected, and it says that one of my stop buttons is on. So you can look for these big red buttons. That means at some point somebody hit the e-stop. So what you do is you push down and spin it in the arrow direction, and it releases. And we can do that with both of them to make sure that they're good. And then click the reset button. Once we do that, we can click OK, and our stop should be a green light surrounded by a red light. As I said previously, I'm going to move this to make a manual offset. If you notice, the board is already cut up really bad here. The way that we've designed our part, we need to make sure that we keep in mind that the Y direction is this direction, and the X direction is this direction. So we've designed our part, and we know that it should fit on our board somewhere, but it's already been cut at the actual origin area. So what we can do is move this entire assembly down to a clean spot on the board. And to do that, I'm going to come back to the software, and we're going to click this little yellow button, and this is going to allow me to move the gantry. So you can either use these buttons on the screen here, or you could use the arrow buttons and page up and page down to drive it. So notice the orientation of my computer matches the orientation of the XY. So if I push right, it will move right. If I push forward, the head moves forward. If I hit page up, the Z-axis goes up. So it's important to keep that in mind. And so what I'm going to do is I'm going to go to a clean spot on the machine where I know that I can cut my parts. Without hitting any of the other things that have been milled. So just double check, that looks good. And bring my Z-axis up a bit. Okay, so now if you look back at the software, I am going to make these new values for X and Y be my new local 0, 0. So it's my new origin. So to do that, you go to 0, X and Y. You don't want to do the Z because we're going to set that up in just a second. So the way the Z works is there's a little connection that you make, and the machine can automatically tell where Z is. So I'm going to go to Cuts, 0 Z axis with Z0 plate, and click that. So it lifts the Z head, and it says hit enter when the plate is ready to 0. So the plate is mounted here. Move the plate down, and we take this alligator clip. We put the plate flat on our piece, and we clip the alligator clip to our actual bit. And this should stay flat. Make sure that it's directly under where the bit is going to touch. We go back to the software, and we click the OK button. And I'm going to hold this down so that it doesn't move. So it's going to go down and touch it, goes back up, and it comes down slower and just barely touches it. And then it moves up to our Z safe height, which is 1 inch, is what it's set up to be here. So now we remove the Z plate. And go back to the software, and it says, remember to remove your Z plate. And focus. So, okay. So now we're actually ready to cut. So there's a few things that we need to do. First, we need to grab safety goggles and hearing protection. We click OK here. Put on our goggles and hearing protection. So far, before we've done anything, or before we've cut anything, the spindle hasn't turned on at all. And the spindle won't turn on unless you plug in and turn this key. And they're smart enough to make you remove the tool before you actually do the key. So now that we're going to actually move our spindle, plug the key in and turn it. The spindle speed is actually already set up in our cut file, so we don't have to worry about that. We're just going to click on Load Part File, and I got to find the circle example cut file and open. Now there is no visual showing you what the file's supposed to look like. So we just know what it's supposed to look like based on the way we designed it. We're going to turn on the dust collection. That's going to be fairly loud. And then we're going to click Start. And it will tell us to push the Start button on our controller here. And that will start the spindle. And then click OK. And it will then begin cutting. So let's go through that process really quickly. We cut on our dust collection. We click Start. And it tells us to turn on the spindle. So we push the Start button. Now the spindle is spinning. The spindle automatically turns off. We turn off our dust collection and we can go look at our part. Now, should something go wrong, this or this button will stop the machine. It will turn the spindle off and all the motors will turn off. It will not move, so it's going to stay in your material. So what you need to do at that point is use the software to manually jog using the up, page down buttons, and lift the Z-axis first, then move it out of the way. And then you can fix whatever problem you have. So now that we've cut our machine, or cut our part, I'm going to move our gantry so that it is out of the way, and we'll go and take a look at what we've designed. And once this is out of the way, I'm going to completely cut the machine off. So I'm going to turn off my software, and I'm going to turn the machine off, turn the spindle off, and now we can come and look at our part. So you can see it created the tabs here, and these pieces aren't going to budge. So we take a razor knife and just remove the excess material. So we've cut all the tabs sufficiently, and then you can use a flathead screwdriver to help you pry it out. And if you try to rip this, try to rip it away from the part, otherwise it can splinter and mess up the finish of your part. But you really want to remove as much of the tab stuff as possible. And so now we have these two pieces that we designed in SketchUp and cut out. We just clean these edges up. The circle we made as a single path. If you look closely, it's actually still not a circle. It's made up of a bunch of little segments. We actually were able to cut a single long cut at once on the machine because we made this, we joined all those segments. Had we not done that, each one of these little line segments, the machine would have cut a little, then gone deeper, and then deeper still, and then it would move to the next one. That takes forever. So we're going to join all of our lines to make a complete line whenever we're cutting. But that's basically how you go from concept to physical parts.